Friends, welcome to Bank Exam Cafe, and in today's episode on Let's Revise 5 Marks question as per the new examination pattern 2021. Here today we are going to discuss few more questions. Friends, this is part 10 and previously we have uploaded 9 parts. And the links of all these 9 parts are given in the description box. In the PDF format, download the PDF and watch all the 9 parts so that you will get an idea that which type of questions will be asked as 5 marks question and how to deal with such questions. Also, download the study material from the description box. Let us move to the first question of today's episode. Let's revise. So here is the first question on the screen. The sum of n terms of 3 arithmetic progressions are S1, S2 and S3. The first term of each is unity and the common difference is 1, 2 and 3 respectively. Prove that S1 plus S3 is equal to S2. Friends, here it is given that the sum of the n terms of 3 arithmetic progressions are S1, S2 and S3. And it is given that the first term of each is unity. It means the first term of each arithmetic progression is 1 and that of the common difference is 1, 2 and 3 respectively. We have to prove that S1 plus S3 is equal to S2. Now friends, here the sum of the n terms of the 3 arithmetic progressions, and that 3 arithmetic progressions are S1, S2 and S3. So here we will find the sum of the n terms of the first arithmetic progression, and we find the sum of the n terms by the formula n by 2 into bracket 2a plus into bracket n minus 1 close the bracket into d. So here it will be sum of the n terms of the first arithmetic progression, that will be n by 2 into bracket 2 multiplied by a, 2a, but a means the first term is unity, so it will be 2 into 1, that is 2, plus n minus 1 into d, and d is 1. Now solve this. So which is equal to n by 2 into bracket, this will be 2 plus n minus 1 into 1 will be 1. So 2 minus 1 will be 1, so it will be n by 2 into bracket n plus 1. So let this be number 1. Now we will see second one. So S2. So S2, that is equal to n by 2 into bracket 2a. A is 1 because first term of all the 3 arithmetic progressions is 1. So 2 into 1 will be 2. 2a plus into bracket n minus 1 close the bracket, and d for the second arithmetic progression is 2 close the bracket. So which is equal to n by 2 into bracket, this will be 2 plus, this is multiply by 2 inside the bracket, so it will be 2n minus 2 close the bracket, 2 and 2 will get cancelled, so it will be n by 2 into 2n, so 2 and 2 will get cancelled and this will be n square. So S2 is equal to n square. So it is second term. Now we will find S3. So S3 that is equal to n by 2 into bracket 2a, a is 1, so it will be 2 plus n minus 1 close the bracket into d, d is 3 close the bracket. So which is equal to n by 2 into bracket 2 plus multiply by 3 inside the bracket, so it will be 3n minus 3 close the bracket. So which is equal to n by 2 into bracket 2 minus 3, that will be minus 1. So inside the bracket it will be 3n minus 1. Close the bracket. Let this be number 3. Now friends, we will find S1 plus S3. So S1 plus S3, that is equal to, S1 is n by 2 into bracket n plus 1, S3 is this n by 2 plus n by 2 into bracket 3n minus 1, close the bracket. So which is equal to, n by 2 will be a common factor, n by 2, inside the bracket this will be n plus 1 plus 3n minus 1, n plus 1 minus 3n minus n plus 1 plus 3n minus 1, close the bracket. So which is equal to, that is equal to, so n by 2, so this 1 and 1 will get cancelled, 3n plus n, that will be 4n, and so 2 1s are 2, 2 2s are 4, so which is equal to 2n square. And so S1 plus S3, that is equal to 2n square, but S2 is what? S2 is equal to n square, correct? So it will be twice, S2 will be twice n square. So twice of n square can be replaced by 2S2, and so which is equal to n S1 plus S3, that is equal to twice of S2, and hence it is proved that S1 plus S3 is equal to twice of S2. Friends, here is a question on the screen. Find the median of the following data. Here the class interval is given as 130 to 139, 140 to 149, 150 to 159, and so on, 190 to 199. And the frequency is given as 4, 9, 18, 28, 24, 10, and 7. And we have to find the median of this data. Friends, here to find the median, we know that we require the class interval in a continuous manner. So this is not a continuous class interval, 130 to 139, then it is 140 to 149, then 150 to 159. So it is not continuous. So to make this continuous, what we do, we first subtract the 0.5 from lower limit and add 0.5 to the upper limit, and so we get the new class interval, that will be 129.5 to 139.5. Now here again we subtract 0.5, so it will be 139.5 to 149.5, because in the upper limit we add 0.5, and in this way we can write all these 149.5 to 159.5, then 159.5 to 169.5, then next is 169.5 to 179.5, then 179.5 to 189.5, and 189.5 to 199.5, and here this is the frequency. And to find the frequency, we first find the cumulative frequency. So cumulative frequency, we first write for frequency as it is, then go on adding the cumulative frequency with the next frequency. So 4 and 9, that will be 13. Then 13 and 18, that will be 31. Then 31 and 28, that will be 59. Then 59 and 24, that will be 83. Then this 83 and 10, that will be 93. and 93 plus 7, that will be 100. And so here we have got the cumulative frequency. We take the total of the frequency, that n is equal to 100. So first what we do, we find n by 2. N by 2. N is 100, so n by 2 will be the 50. And then the cumulative frequency just greater than 50 is what that we see. Just greater than 50. That cumulative frequency is 59. So this is the frequency, cumulative frequency, that is just greater than n by 2, that is 50, and therefore the class interval corresponding to this cumulative frequency is called as the median class. So we write that median class that is equal to 159.5 to 169.5. And so here we got the median class. Then after getting median class, we take the lower limit and it is denoted as L. So lower limit will be 159.5. Then we find the frequency that is which is corresponding to this median class is 28. So we take this frequency, so F that is equal to 28. After that we take cumulative frequency just before that of the median class. So this is the cumulative frequency that we take. So cumulative frequency that is equal to 31, and then we require height. Height means the difference between these two, upper limit minus lower limit, and that difference is of 10, so h will be equal to 10. Now once we have got all these things, we use the formula to find the median. So median that is equal to L plus into bracket n by 2 minus F cumulative frequency CF upon F, close the bracket, into H. Now put the values. L is 159.5 plus into bracket n by 2 that we have got as 50. So 50 minus cumulative frequency, that is 31. So it is 31 upon frequency is 28, multiplied by h, that is height, and that height is 10. Now solve this further. So here it will be, which is equal to 159.5 plus, solve this first. So it will be 19 by 28, 19 by 28 multiplied by 10. And so which is equal to 159.5 plus, if you solve this part, you will get it at 6.79. And add this together, you will get it as 166.29. And therefore the required median of the given data is 166.29. So friends, in today's episode we have discussed two questions, one from the statistics, and I hope you must have enjoyed this video. If yes, please like the video, share it with your friends, and do not forget to subscribe the channel. Thank you very much for watching this video.